Good morning.
Good morning.
Good
Good
morning.
morning.
So anything exciting going on today?
We have volleyball games today against Mogion.
Nice.
That's pretty exciting.
Nice. So what time do they start?
Freshman plays at 3, JV plays at 4, and varsity plays at 5.
Nice. All right, that sounds like a good time. All right, what else is going on? Nothing?
Matilda is still going on.
Oh yeah, so are you in that one?
I'm running sound.
Oh, okay. So if that's kind of my pet peeve when I go to
Yeah, I know.
different shows.
It's mine too now.
Different places is if the sound system doesn't work, especially when I think the acting is great and the singing is great and the sound is bad, then I think, what's wrong with, these kids are working so hard and then some guy can't run the mic right, so that'll be you, right? So
Yeah.
okay, all right. Well, I'll know who to vent my frustration. No, hopefully it's awesome. I haven't heard anything bad about the sound, that's for sure.
All right, that's good.
And Julie went last night, so I think we've got tickets for closing night. So anyway, so let's see. So is anybody who's gone there? And okay. Now I think everybody's there at Joseph City, right? And how about Holbrook? Are we missing anybody?
Raylan.
Okay. Oh, I'll tell you, there was that college fair at Flagstaff tonight. I would highly recommend that to anyone if you're thinking about going, just kind of making some connections. Anyway, I know I went to one of those things, and I credit at least 2 of the scholarships I got to just going to that and talking to people. And so I would highly recommend it if you're able to go. Anyway, all right. Well, let's see. So today we are on starting on 3.4, and okay. So okay, so let's see, what's today? Thursday. So we're looking at the schedule for the midterm, and it's going to go over 2 days, and I'll break down like the specific problems and stuff. Give you a little more detail on Monday, but number one, I would recommend that you start doing like some of the either the practice problems in the book for after each chapter, or you could look over some of the quizzes and tests that we've done, just to start prepping. The midterm will cover through 3.3. So chapter 1 through 3.3. So I'm looking at either Tuesday and Wednesday of next week, or Wednesday and Thursday of next week. And I'm just wondering, does anyone have a preference, or do you know, would it matter? Tuesday, Wednesday, or Wednesday, Thursday?
I think our class would prefer Wednesday and Thursday.
Wednesday, Thursday? Okay. So I will probably, after I talk to my afternoon class, and actually we wouldn't even have to do it necessarily at the same time, but I will go ahead and probably send out the emails to the talent instructors either this afternoon or tomorrow morning, and after I make a final decision. But probably, I think Wednesday and Thursday would be a good time to do it. But for sure next week we're going to have the midterm. Now the midterm it's weighted the same as all of the. I mean, it's almost as much as all of the quizzes and all of the quizzes put together, all of the tests put together. It's over 20% of your. Well, it is 20% of your final grade. So, with the exception of the final, the midterm has the most influence on your overall grade. Now, I do want to let you know that I do curve the midterm, and so I do that based on all of the classes. So, like if the highest score if the highest score is like a 95, then I'll give everybody 5 points. If the highest score is a 90, I'll give everybody 10 points. That kind of stuff. Let's see here. Oh, sorry. Okay. All right. So let me just kind of give you an idea of, okay, so like right now, the quiz average for everyone in the entire class, the quiz average is an 86.5%. Okay. So we're doing good, and we're doing good on the quizzes for the most part. The tests, not quite as good. Like the last test that we took, the average was a 76.48%. Now, while that's still getting college credit, that average, I would certainly like it. I think the goal is, for me, I would love it if when the overall average is at least 80. Okay. But just so you know, on the last test, even though the average was 76.48, that let's see. I guess let me check the other class too. Because I'm just curious now. Okay. All right. So, yeah. So the highest score of all the classes for the Chapter 2 test was a 96. Okay. So if that were the midterm, then I would be adding 4 points to everybody's score. Now you might ask, well, why don't you curve each individual test? I kind of do at the end. I actually do kind of an overall curve based on the overall scores, but I don't do each individual test. Let's see, on the Chapter 1 test, I did have one student got 100 on it, so there would be no curve on if I did that. So the midterm, I will look at everyone's score, and then after I do the curve, then I go in and physically change everyone's midterm grade, and and of course I'm not going to lower it. You'll just get those points added to it. Okay. Let's see. Now, and usually I have this conversation after the midterm, but someone had emailed me, and so I'm going to just kind of talk about it now. Usually after the midterm, especially if someone bombs the midterm, then they're like, well, what do I do for extra credit or whatever? Number one, the midterm is going to have a huge impact on your grade. And if you were to do well on the midterm, your your overall grade would go up. So the number one thing you could do right now is study for the midterm. But and then the second thing, as I say, is that there's a lot of points, there's a lot of grades in my class. It's not like I took one class in college where we only had one grade. It was the final exam, and whatever you got on the final, that was your grade. Okay, I hated that. You talk about pressure and anxiety. But you have a lot of grades, so if you bomb a quiz or two or a test, you're going to be okay. You can still do well. The third thing I want to say is that I do also offer some extra credit at the end of the semester. I have two things that I do for extra credit, but there's nothing like that will help your grade better than getting an A on the midterm. So that would be my recommendation to you right now. If you want to improve your grade, study for the midterm, practice, maybe even, in college when you're in the dorms or something like that, you form study groups in the library for some of your harder classes and you work together. I had a class, a math class, where we've had to form a study group because I wanted to get an A in that class and I was getting a B. And so I got together with some people every day after class. We met in the library for a couple of hours and worked on homework and so on. And I don't think it was any coincidence that everybody in the study group got the highest grades in all the class. And so I would highly recommend that, because when you go off to college or university, you're going to probably want to do that anyway. So I would recommend that. And some of you have, open periods or whatever where you could get with someone, whatever. So that's my recommendation to you as far as your grades go. The other thing, and I'm not quite sure I understand this, and maybe somebody could help me, but I don't understand people getting a lower score on the second attempt. And I don't know, this has happened more this semester than probably all my years teaching for NPC. And it makes me, I'm been so frustrated because I want the second attempt to help your grade. And I'm like thinking, it would just be easier if I just didn't do a second attempt. That whatever you got on the quiz or the test, that would be your grade. Because again, I'm maybe you guys can help me understand this, but when you look at your grade, it either tells you got it right or wrong, or you can see the points. If you got the points, you got it right. If you didn't get the points for that question, you got it wrong. And it seems like if you're working out the problems on your paper and you know how you answered, then when you go to the second attempt, you would start with those questions and make sure that if you already got the points, you would get those points for sure. And then the how many questions you got wrong, then focus your time on that. But it seems like you would start off with the points that you had, so at the very worst, you would get the same score. But I don't understand this getting lower scores, and it's almost like every day I'm getting an email from a student saying, I got a lower score on the second attempt. Can you delete that attempt or something like that? Or give me a third attempt or whatever. And I'm just not getting it. So can somebody help me out? I mean, because literally I'm almost to the point where I'm just going to not do second attempts anymore.
A lot of us like the second attempt, so I'd be really disappointed if you did that.
I think I would too, and I think that they're hard enough that the second attempt is kind of a fair way to do it. But anyway, you're going to say something, Avery?
I've done worse on the second attempt one time, and it was because I opened it right before time ran out, so it closed it,
Okay.
and then marked them as wrong.
Okay, but as you've learned the deal, so
Yeah,
I guess as I go over the syllabus, I probably or at least before the first quiz, I should probably emphasize that a little bit better. Anything else? Well, I'm not going to do away with them just yet, but I'll tell you, it's after you read email after email every day, at some point you're just like, oh, I give up. But
Have you ever thought about taking the higher grade instead of averaging them?
yeah, as a matter of fact, I started off doing that. And so the reason why I stopped doing that is because then on the first attempt, a lot of students were just guessing randomly. And then they would only work on the problems that they missed. And see, I found that as an instructor kind of offensive. It bothered me because then they weren't really learning, and it wasn't really showing me what they were learning. It was showing me how good of guessers they were. And so that bugged me. And so I'm like, okay, if we're going to play that deal, because, you know, on a 20-question test, I would have a student that finished it in, 80 seconds. And then the second attempt, they would spend, 20 minutes or whatever working on whatever ones they missed. But anyway.
So in that instance, you as the instructor, you can see how long it takes them, right?
Oh, absolutely.
So if their first attempt is like pitifully timed, like it's completely just bogus, can't you go in and affect it then? So then not everybody would get
and do what?
For it.
And do what?
Take their average, I don't know, maybe.
See, that's kind of like, I can tell, like, if a student says, I didn't have enough time, and they started a half hour late on their test or something like that. See, there's a lot of things. Then do I go out and say, look, I'm not giving you any extra time because you didn't log in on it. I don't know how mean I want to be. You know what I'm saying? I could go in and analyze all that kind of stuff and then say, well, you didn't do this, so therefore I'm going to sock it to you. I kind of don't want to micromanage to that point. Part of it is, I think, you just natural consequences. If you don't start on time, well, you just don't have enough time, and that's on you. But yeah, when I have you do evaluations at the end, that's actually going to be one of the extra credit opportunities. Or really any time, if you do have some ideas on what I can do better, and sometimes it's out of my control and out of your control. But I have tried to do some different things, and I really think what I would like to have happen, this would be, and I might have mentioned this before, but what I would like to have happen is they're working on an online proctoring deal where you have to, anyway, there's different things that you can do for online proctoring. And if we were to adopt that system, then I would just like to say, here, you have 3 days to do this quiz, do it whenever. And then we don't have to involve Ms. Smith or Ms. Buckley. It's just you and the computer, and then you'd have a little more flexibility as far as when you scheduled all your attempts. But until we get to that point, we got to do what we got to do, I guess. So anyway. All right. Well, on Monday, I'm going to give you the breakdown of the midterm. And we'll talk about the time, we'll talk about the questions, and so on. So just at the beginning of class, we'll do that. All right. But let me go ahead and let's do a little bit of math here today. It always makes me happy to do math. So, okay. So section 3-4. So again, this material will not be on the midterm. It will be on the final. However, all right. So, whoops. So this is on what's called variation and multivariable functions. And so there's three kinds of variation: direct variation, and inverse variation, and joint variation. Now, these little arrows here are kind of how I remember how I remember them, just visually. Direct variation is as one variable goes up, the other one goes up. Or as one goes down, the other one goes down. Inverse variation is as one variable goes up, the other variable goes down. And then joint variation is kind of a combination of it all. Okay, we'll talk more about that. And then multivariable functions. All right, so we say that y varies directly as the nth power of x if there is a non-zero constant k such that y equals k times x. Now, n could be to the first power. A lot of times it is. So it might just be y equals kx. But you could have an exponent on there. But when it varies directly, it means there's a number that you multiply by. Okay? So the idea is that as one thing goes up, the other thing goes up. So, or if one goes down, the other variable goes down. So can you think of something, two things that would vary directly?
When you say two things, are you saying two like equations or
Two things in real life. As one thing goes up, another thing goes up. So how about your height and your shoe size? As you get taller, does your shoe size get bigger?
Yes.
Typically, yeah. Now, in all of these examples, you could find the exception, but we're just talking about in general. Okay? All right. Let's see. How about?
Seth's got one. Seth came up.
Okay, go ahead.
As you sell more products, you get more money.
That's right. Okay. So direct variation for drug dealers. No, we weren't talking about dealing drugs, right? No, anything. As you sell more products, you get more revenue. Any business. Okay? Or how about as you, let's say in basketball, as you shoot more shots, you get more, your points go up. Okay? Typically. All right? There was another one in Holbrook somebody had. Okay? So how about the number of hours you study and your overall average in a class? Typically, that's a direct variation. Okay? So usually how these problems work is that you want to find k first. And k is what we call the constant of variation. And so you find k, and then you can answer the question, find x or y.
Mr. Strong,
Yes.
is K kind of like the slope?
K is kind of like the slope, but it's not always are the equations lines. So like if you had kx squared, then k wouldn't be the slope in that case. But it's kind of like that idea.
Okay.
It's a rate of change. Okay? All right, so let me go through this example here. And so it says y varies directly as the square root of x. Now, the way I would recommend that you do these problems is sentence by sentence. Okay? So you see how I have the slash here, the blue line? Okay? You just stop right there. Okay? Y varies directly as the square root of x. And you just translate that problem. The first part of the problem is going to give you your equation. So if y varies directly, then k is multiplied by the thing. And so y equals k times the square root of x. So you could put the square root of x or x to the 1/2. Either way, this means the same thing. So from this first sentence, you write one of these equations. Okay? All right, then it says y equals 36 when x equals 16. Okay, stop. You stop right there. And so that bit of information is going to help you find k. All right? So you plug in 36 for y and 16 for x, and then you solve for k. All right? So that gives you 4k equals 36. Divide each side by 4, and you get k is equal to 9. Now you go on to the last part, and it says, what is y when x is 20? Okay? So now you take the k that you just solved, and you plug that back into whichever of your original equations that you're using. So y equals, so instead of 9 k radical x, we plug in the 9, so it's 9 radical x. Then now you say, what is y when x is 20? So now in place of x, we're going to plug in 20. And so now we work that out and either simplify the radical or write it as a decimal. It doesn't matter, however you want to do it. But you plug in the x value here and you get y. Or sometimes you'll plug in a value for y and solve for x. Okay? All right. So see if you can do practice 1A. So do it like I did in those 3 steps. So you can even draw the lines through the equation if you want, or through the words. Okay, so Sierra, so suppose that y varies directly as x. So what's the formula that we start off with? What's the equation?
Would it be y equals kx?
Yes. So it's y varies directly as x. So it's not the square root of x, it's not x squared, it's just x. Okay? So this is kind of the most basic one. Okay? Good. All right, so Jocelyn, using the second part, y equals 36 when x is 18, what is k?
K equals 2.
Okay. So you plug in 36 for y, 18 for k, and you get k equals 2. Then you take the 2 and you plug that in up above. All right, and now to answer the question, Hannah, what is y when x is 20?
Y equals 40.
No, y equals 40. Excellent. Okay. Any questions on that? Okay. All right, so one of the applications of direct variation is in physics what's called Hooke's law, and it has to do with springs. So like a spring that, where something's suspended by a spring and it could bob up and down. Hooke's law says that the force exerted by a spring in a spring scale varies directly with the distance the spring is stretched or compressed. And so we could write that y equals kx, or like in physics books, they would write it as F equals kx. And so they just use F instead of the y. F is the force. So it's the same thing. Whether you want to use y or F, it doesn't matter to me. But this is known as Hooke's law. Okay? So Hooke's law is y equals kx, or y equals F equals kx. Okay? All right, so it says Hooke's law says that the force exerted by the spring in a spring scale varies directly with the distance. Okay, so you just stop right there and you write the formula. Y equals kx, or however you want to write it. Okay, then it says if a 5-pound mass suspended on a spring stretches the spring 2 inches, okay, so you stop right there. And you're going to use that information to find k. All right? All right, so that's going to give you, so 5 is the mass, the force. So you plug that in. And then k is the distance. So it's stretched 2 inches, so the 2 goes right there. And so then when you solve that, you're going to get k equals 2.5. All right? Now you plug that back into the problem, so you get F equals 2.5d, or y equals 2.5x. It doesn't matter what variables you use. And now you answer the question, how far will a 13-pound mass stretch it? Okay, so the 13 pounds, do you put that in for the F or the D?
F.
That's the F, because you're wanting to know the distance in this one. So you put 13 here, solve this for D by dividing each side by 2.5, and you get D equals 5.2, 26 fifths, or 5.2. All right, any questions on that? Okay, now on the practice problem, I don't think I corrected this. I accidentally used the very same numbers that I had up here. What I've done now, so I've changed 5 to 6. So you want to change that to 6. And the spring, let's see, this is now 3 inches. And how far, and now this is a 10-pound mass, stretch it. Okay? So make those corrections on your paper and then go ahead and try that one.
Hey, Mr. Strong.
Yes.
I'm just curious. So when it says varies directly as like say the product of something, does that also work when you say it varies directly as the sum of something?
No, well, no, you wouldn't. You wouldn't have a sum. You would have. You could have a quotient, but that's varies inversely. We're going to get to that next.
Okay.
But
Thanks.
yeah, it wouldn't be a sum, no. All right, so Jocelyn, when you've got K, let us know.
K equals 2.
K equals 2 is correct. Very good. All right, so Ricky, when you've got the final answer.
5 inches.
That is correct. Great job. Okay, any questions on that? All right. So direct variation is usually fairly straightforward. The thing is, you just on these problems. I mean, it sounds weird to say, but a lot of times it's more of a test of your reading, not your math, because you have to read it very carefully. Okay. All right. Now let's go on to inverse variation. We say that y varies inversely as the nth power of x if there is a non-zero constant k, such that y equals k divided by x, and x could be to a power even. So this means as one thing goes up, the other thing goes down. Okay? So, and then here I've got just a comparison. So direct variation, y equals k times x. Inverse variation, y equals k divided by x. All right, so can you think of two things that would vary inversely?
Is that how supply and demand is?
Okay, so supply and demand. As demand goes up, supply goes down. Okay, perfect example. All right, and that, anybody else? Have an example of inverse variation?
Well, if you like drink water, then the water's gone from the cup.
Okay, all right. Or if, let's see. What was the one I was just thinking of? Okay, as your spending goes up, your bank account balance goes down. Okay, all right. So that's a good example of inverse variation. Okay. All right. So again, I kind of approach these the same way. So suppose that y varies inversely as the square of x. Okay, so just stop right there and write the equation. So that would be y equals k divided by, so it's the square of x, so that's over x squared. Okay? So that's step 1. Step 2, and that y equals 3 when x equals 4. So that's the part you're going to use to find k. So you plug in 3 for y and 4 for x. And so now to solve for k, you multiply, square out the 4, multiply by 16, and you get k is 48. Now you take that k and you plug it into the formula. So y equals 48 divided by x squared. And so now you're able to answer the question. So the question says, what is y when x is 8? So you plug in 8 for x, and you simplify it, and there's your answer. Okay? All right, so see if you can do practice 2A, please.
I think there might be a typo because it says y varies inversely as y.
What? Oh, on the paper?
And it
Yeah.
says solve for y. Are we supposed to know?
Yeah, y varies inversely as x.
Okay.
So, yeah, change that. Thank you. I'll make a note of that. So it should say y varies inversely as x. Let's see if I change it up here. Yeah. Okay, Andres, what did you get for K?
K got 42.
All right. K equals 42. Any questions on that? All right, so Jill, when you've got the final answer.
I got x equals 2.
X equals 2. Excellent. Okay. Any questions on that one? All right, great job. Okay, so to solve a variation problem, these are the same steps that I've been going over every time. First, write the formula that you need. Okay, make sure you pay close attention. Is x squared? Is it the square root? Is it just x? What is it? Okay, then you find k, then you answer the question, solve the problem. All right. Okay, it says the weight of a person relative to the earth is inversely proportional to the square of the person's distance from the center of the earth. All right, so let's stop right there. So what equation am I going to write here? Anybody?
Inverse.
So what equation? So it's inversely proportional. So how do I write that?
F equals K over D to the nth power.
Okay, so but it's squared. It's proportional to the square.
Oh.
Okay, so it's their weight equals K over R squared, or you could do Y equals K over X squared. Okay, again, the variable choice is up to you, but it's inversely proportional, so you know it goes in the denominator, and the square of the distance from the center of the earth. So I thought of that as radius. You could write it as x. Okay, now it says using a radius for the Earth of 6,370 kilometers, how much does a 180-pound man weigh when flying in a jet 9 kilometers above the Earth's surface? Okay, so when he's on the Earth's surface, he weighs 180 pounds. So we're going to use that to find K. All right? So we're going to plug in 6,370 for R and 180 for W. All right? So see if you can solve that for K. All right, so Andres, what's K?
It's 7,303,842,000.
Oh, you got it.
All right. And you could put it in scientific notation. Okay. And then, okay, so then I put the K in the formula. So W equals K over R squared. Okay, now we want to figure out what a person weighs when they're in a jet 9 kilometers above the Earth. So we're looking for W. What do we put in for R? What do we plug in for R this time?
You do the
9.
Is it just 9?
You have to add it to the radius of the.
You have to add it to the radius of the Earth. So it's the radius of the Earth plus 9 more. Okay? So you're going to have 6,379 is going to be your R, is what you're going to plug in for R. All right, so that's just a calculator thing. All right, so Anna, when you've got it, let us know what the W is.
$179.492.
Okay. 179.492. So you lose what, a half a pound. Okay, so there might be easier ways to lose weight than getting in a jet and flying up in space. Okay, but it actually does work. Okay, so any questions on that? Okay, so we say that z varies jointly as x and y if there is a non-zero constant k such that z equals k times x times y. So if it's jointly, then that means that you could have another variable, okay? But it's all direct. Combined is where you could have one of them be direct, one of the variable have direct variation, and the other have inverse variation. So it's a combination of the two. So that's called combined variation. Okay? So this is a formula from this part. What kind of variation is this? Is this joint or combined? This formula.
Combined.
It's combined because see, if it just had this top part, it would be joint. But when it's combined, when you have multiplication and division, then it's going to be combined variation. And so that's a formula from physics with the force. Okay. All right. So let's look at practice 3. Okay. So it says z varies directly as the square of x and inversely as y. So that's combined. You've got direct variation and joint variation in the same problem, but you only use one k. Okay? So see if you can just write the equation for that. So just we're stopping at that first period. All right, so Desiree, what would be the equation we'd start with? So z varies directly as the square of x and inversely as y.
So
I got z equals kx squared over y.
Yes, beautiful. Okay. Any questions on that? Okay. So we're running out of time here. So what I want you to do before class on Monday is I want you to finish up this problem. Okay. So first you find k, then answer the question. All right. Any questions or comments before we get cut off here? All right. Well, good luck. Have a good weekend. Good luck against Mogyan tomorrow. They're talking trash to me. We got to back it up. We got to get them. Okay? Counting on you, Jay. So you guys have a great one, and we'll see you Monday.